So, as Michael said, I'm the founder of Notion. One of the things that I do a lot of is I'm a product hacker, so I do a lot of prototyping with APIs, and so AT&T asked me to come in, and I've been using the Speech API for a few months now, trying to see what the ins and outs are, and I developed a Node.js wrapper for working with the Speech API over the web. And let me tell you, the easiest part of working with the Speech API is the actual API interface. The audio capture interface is definitely the hardest part, and the one that's most problematic right now. But we've got some solutions for that on mobile devices with SDKs, and we have a sample recorder that, as you saw, had a few issues because of Flash, but we're hoping that we'll get through those pretty quickly. And so I wanted you to go and meet Jay Lieske. He is here to tell you a little bit more about the Speech API.
Thank you. Well, I'm really excited to be here and have you guys all here learning about AT&T Speech Technology. I'm part of the AT&T Speech Technology team, and we've been all working many years on AT&T speech recognition systems. And now, through the AT&T Speech API, the stuff that we've been working on for so long is accessible to your applications, and we look forward to all of your users getting good speech recognition from our systems. So AT&T Speech API is a client-server speech recognition system. This is a schematic diagram of how it works. So at the top are the clients. These are the applications where you want to add speech recognition. The clients can be mobile devices, they can be desktop computers, they can be web applications. They can be anything that can send HTTP, that can run the HTTP protocol and send audio data. At the bottom are AT&T speech recognition services. So when your app wants to do speech recognition, you're going to start at the client. The client's going to send audio down into the cloud to the AT&T speech recognition servers. At the core of that recognition system is the AT&T Watson engine. Watson will process the audio, it will turn the audio into text, and then it will return the web server response back up to your client. Now, Watson is really the core intelligence of the system. And AT&T's been developing Watson for more than 2 decades. AT&T researchers have been studying how people interact with voice-enabled systems. And they've used that knowledge to build up a powerful speech recognition engine. Now, one of the key aspects of how we're sharing the power of Watson through the Speech API is we have what we call 7 speech contexts. These are speech recognition systems that are tuned for certain use cases. They know the vocabulary of how people talk differently in different situations and the different kinds of grammar that they use. Like the first one, web search is oriented towards the keywords people might say in a web browser. And it's just tuned to that. You don't use web search for like full dictation. You use it for getting keywords, and it's going to be highly accurate for that. Business search knows locations like cities, it knows business names, it knows business categories, so you use that for a location-based service. Question and answer knows phrases that are in the form of questions, like, what is the capital of California? Doesn't answer the question for you, but at least it recognizes the question. Voicemail to text is oriented towards processing voicemail, the long, kind of the sentence-oriented things that people might leave in a voicemail system. SMS Package is almost the inverse of that. It's oriented towards the short texting phrases and abbreviations people want to transmit over a text. So you'd use that so someone could dictate an SMS message. The TV and UVerse applications, it's not limited to UVerse. It's actually tuned with actor names, TV show names, movie names, TV channels, so it's oriented towards media applications. And if none of those use cases are right for your application, you can use the generic package. And that is oriented towards full sentences, one sentence at a time. So in the Speech API, there's one REST web service, which performs speech to text. It turns audio into text. And it's a simple REST web service, which means that you create an HTTP post, you put audio in the body of that post, you send it to the server. It'll accept audio in either WAV or AMR format. AMR is a highly compressed format oriented towards voice, and so it's best for bandwidth limited situations like mobile devices. WAV can be easier for desktop applications or when you're developing. There are some specific requirements on the subtlety of WAV format, so you'll need to refer to our documentation to make sure that you're sending the right version of WAV. In response to the audio that you send, you'll get a JSON document back. And Michael will go into some detail during his part of the talk about the format of that response. But two things I want to highlight. First, obviously, it includes the text that was spoken by the user. But it also includes evaluate metrics like confidence scores. That's a measure of what the speech recognition system thought its performance was when it was trying to evaluate and convert the audio into text. So you can use those confidence scores to help your app make a decision. Is the speech clear enough? Was the absent recognition good enough to give back to the user? So as I mentioned before, you can use any client software that you want with the AT&T Speech SDK. Anything that's speech HTTP. We also offer some SDKs that might accelerate the process of your development. I want to point you to the AT&T native SDKs for iOS and Android because my team develops those. And we'll be having a breakout workshop after the presentations where if you have questions about the SDKs or for web programming with the Speech API. The key advantage of our native SDKs is they do the hard work that an app needs to do when running on a mobile device. Getting the data from the microphone and streaming it over the network to the server. The advantage of the streaming is that the speech recognition can happen on the server while the user is still talking. That means the recognition happens, the result comes back faster, and the user thinks your application is running faster. So we want to encourage you to use streaming. There are several applications using AT&T Speech technology out there. These are three of the applications on mobile app devices from AT&T. First is Translator. Translator understands several languages and it can translate between them. So, like, I could speak in English to it and it can speak back. It'll translate it to another language that I don't speak, like French, and it can actually speak out the French words so that someone could, let someone hear it. Or I can hear it myself to hear how French should sound. Or you can have someone speak a foreign language into it and it'll translate it to English. In the middle is Speak For It. Speak For It's an application that my team at AT&T has built. And it's a local search app that integrates touch on the screen with voice. So that, this is sort of the screenshot, you can touch a place on the map and say what you want to find there. The third app is the Uverse Easy Remote. This is a new application for AT&T's Uverse TV service. And it's a voice-activated remote control. And it's oriented towards people who are visually impaired. And it gives them deeper access to the programming on their TVs. So with the Uverse Easy Remote, you can say what you want to watch, and it'll tune the TV to what channel that's on.